All right, everybody, we are live from Atlanta, Georgia on the campus of Emory University for the virtual Star Party. I am Tim Farley. Hi. I am the host here, and other people will appear on this screen, other speakers from here at the Star Party. But right now I'm going to throw it over to Scott Lewis, who is going to tell you who else we have on the panel.
Hi everyone, welcome to a non-regular virtual Star Party, but it's Nicole's face sticking her tongue out at me. I've missed you. So this is a special event. This is our third year here for the 6th annual Star Party in Atlanta for Dragon Con. And so we have brought our astronomers from the VSP and also some special guests. So I have recruited last minute to bring us David, Dr. Funky Spoon, which I've always promised I would scream that on air whenever I see him. So here is David Grinspoon, an amazing astrobiologist, I believe is your technical designation now, or what are you?
What am I?
What are you besides like amazing at everything?
Well, I'm an astrobiologist. I'm a senior scientist at Planetary Science Institute, and I'm a distinguished visiting scholar at the Library of Congress. But you can call me whatever you want, just don't call me late for supper.
So, do they give you Geritol now that you're a senior scientist?
Yes, they give.
Awesome. Sweet.
You know, that's one of the cool things about working at the Library of Congress. They give you whatever you want, including Geritol.
Geritol and Depends. It's all cool. Also with us is one of my favorite people in the world, Dr. Katie Mack, coming from us from Melbourne, Australia.
Hello.
In the future. So it's what?
Yes.
What time is it there? Noon?
It's 12:42 on Friday.
So from the future. So we have our amazing PhD astronomers joining up with us, which are tried and true astronomers. We have Gary Ganella coming from close to my neighborhood in the Los Angeles area. How you doing, Gary?
Hey, good. You know, we've delayed long enough. In about 10 minutes, I can start getting images.
Oh, cool. Yeah, it is getting dark out. So sweet. It's all worked out.
If you'll excuse me, I'll go get the scope set up.
There's no excuse for you, but that sounds fine.
That's for sure.
And also with us is a good friend of mine and also one of our regulars from the VSP is Stuart Foreman. How you doing, Stu?
Good. How are you?
I'm doing great. And you have some amazing images, something that I've been actually playing with today in Photoshop that we're going to be sharing later with the Comet C2014 E2, better known as Jacques. And we'll be showing that a little bit later on. So, hello everyone in Atlanta. Hello everyone on the internet. I'll be tweeting stuff out here as we're going along. I have a lot of wonderful astrophotography that we'll be sharing out from the other astronomers that were not able to join us live. I have like so much that we won't have enough time to go through them, so I will try to pick the best for everybody. If you want, I believe most everyone here has their Twitter handle at the bottom. So Stu is at S24Man. David is at Dr. Funky Spoon. Katie is Astro Katie. And Gary's is his ham address, which is not down there, but we'll find it later. And I am at Scientific Scott. So feel free to tweet at us as we're doing this out. Send out the YouTube link as soon as I send that out, so if you want to retweet that. And the first image I want to share while everyone is getting set up is from one of our amazing, brilliant astronomers from Turkey. His name is Ahmet Kale, and it just blows me away with everything he does. This is his latest of the Andromeda Galaxy, and it's headed right for us. I just can't believe on the amount of detail he's able to get out there. The dust lanes, the satellite galaxies.
Wow.
But since we have someone that works a little bit in dark matter and larger structures, Katie, I was wondering if you can tell us a little bit about this, our closest big galaxy headed right for us. Can you give us a little bit of a scientific explanation on what's going on?
Sure. So first of all, this is an amazing photo. I love the colors on that and everything. So Andromeda is a neighbor galaxy to ours. It's about twice as big, and it is indeed heading right for us. The Milky Way and Andromeda are gravitationally bound, and we're coming together. And I think the collision date is something like 4 billion years from now. So unfortunately, we won't get to see it, but it will be really cool. We'll get like beautiful new sort of stellar like slide, like light show in the sky. There'll be all sorts of cool like stellar streams going on, and this sort of big train wreck of galaxy collisions. We might get some star formation. That's often triggered by collisions of galaxies. That'll be really cool. Probably the Earth will still stay going around the sun. That probably won't be affected because there's actually a lot of space between stars. So even when galaxies collide, star systems tend not to collide with each other directly. But of course, by that time, the sun will be expanding, and we'll probably all be dead anyway. But it should be really cool to watch for whatever kind of machines are still around taking pictures.
This is a sensational process, and it's a notoriously difficult galaxy to process because it's so big. As you can see, it fills this whole field of view. And the core, when you just take pictures of it, the core will blow out the limbs. So you have to do it in multiple different levels and layers. And he just did a sensational job with this.
And I was muting while I was tweeting. And so since we have an astrobiologist, and we were just talking here about life on Earth not really being around here, what do you think this means for us in 4 to 5 billion years? Obviously, we're not really going to be the species we are now, because our species has only been around for a couple 100,000 years. What do you project is going to happen when these two galaxies collide and become Milkdromeda, or whatever we want to call it?
Well, I'm just looking at this and thinking about the fact that we've recently learned that in our galaxy something like 1 in 5 solar-type stars has planets potentially in the habitable zone, and presumably that's typical. And Andromeda, as far as I know, and you astronomer types, astrophysics types can correct me if I'm wrong, but it's approximately the same. Well, it's the same age and roughly the same size as our galaxy, isn't it? And so I'm looking at this and I'm just thinking, there's so many planets on so many stars there, and there's so much potential for life. And so, as Katie said, in 4 billion years, it's very unlikely that we'll be here. I mean, you and I certainly won't be. Some descendants of ours, some machines we build, who knows what's going to happen with this human experiment, this Anthropocene experiment on Earth. But what I'm thinking is that somebody will be around. There's so many planets and so many different stages of development that, unless there's something really wrong about our assumptions and our what we've derived about the universe, and there really is something freaky about Earth, which doesn't seem to be the case, then there's got to be a lot of planets in different development and different stages of life, and so somebody's going to be around to watch that happen, and that's
it's going to be me, because I totally believe the singularity is going to happen, and I will live forever. I will become part robot.
And Ray Kurzweil says
that is the most terrifying thing I've ever heard, Scott.
Ever. Hey, that's what I'm here for.
Well, Ray Kurzweil says that people alive now will be able to live forever, right? So, I mean, maybe Ray Kurzweil will be around to watch it happen.
It's true. And we're joined by the bad astronomer himself. Welcome, Phil. How's it going?
Hi, everybody.
You know why he's so bad? Because he's not here with us this year.
Yeah.
Shut up.
There's a tear. There's a tear.
Hey, which finger is that, Nicole?
So, welcome aboard, Phil. We just got done talking about the inevitable doom of the human race with Andromeda coming at us, and we're already going to be dead in the singularity. So we're off to a happy start.
The singularity.
Yes.
Yes.
But I want to get something a little closer to home, and this is something that Stu, who's with us tonight, he captured this on Saturday and blew my mind. He sent me the stills earlier, and so I was able to animate it. And this right here is Comet C 2014 E2, better known as Jacques. And Stu, if you could give us a little insight on what was going on here. I know that someone told you to capture this while you were doing something else.
Right, so I was doing something completely different in a completely different part of the sky, and I was just getting some hydrogen alpha on the Crescent Nebula, and I tweeted Paul Stewart, and he goes, "Oh, that's great. Why aren't you getting the comet?" And I went, "What comet?" And so he gave me the coordinates. I slewed over there, and then he helped me frame it. And I ended up getting some LRGB, that's luminance, red, green, and blue. And this is the luminance channel, 8 frames of 2 minutes each. And you can see how fast it's moving. And each of these frames, there's 8 of them in here, is 8 minutes, 2, 4, 6, 8 minutes apart. So it's moving pretty quickly across the field of view. And I saw this, and I just started jumping up and down because I just got really excited. I said, "I've never seen this before," from one of my processes. And I think I sent you the color image as well.
You do, yeah. And I'll show that out later.
Yeah, I'll show that later. But
so, is there any risk of any death from the skies with this by any chance?
Well, I'll defer to the Death from the Skies master.
Yep, we're all doomed, so we better give more money to the Atlanta Star Party.
Well, I have the Universe is Trying to Kill You t-shirt on, so...
There you go.
How bright is this comet right now?
Right now it's about, when I did it on Sunday, it was 10th, and I think now it's about 8th.
Nice.
It's going to get, I think it's to its closest approach, like tonight or tomorrow.
Yeah, I think it's tonight.
Yeah, tonight or tomorrow. So tonight, I think it's 8th magnitude.
And this is up in Cassiopeia, right?
Not anymore. It's moved on. But when I shot this, it was in Cassiopeia.
Okay.
Yeah.
So,
Awesome.
so as a theorist, can you remind me what 8th magnitude looks like in the sky? Like, is that like? No, I mean, is that naked eye or what?
If
I love you.
Yes. If
Nicole's a radio astronomer, and she's laughing at it.
I know.
Naked eye, you could see it. From where I live in suburbia, I couldn't see it naked eye, and this was 10th magnitude. But I think your naked eye in like a really, really dark site, if you have really good eye, can get down to what, Phil, about 10th or 11th magnitude?
Oh, naked eye?
Yeah, naked eye.
Maybe
I'm
6.5 or 7.
Oh, really?
If you're really good.
Yeah, okay.
Yeah, so this is a binoculars object tonight. It's raining here, so probably not
And
here.
I have no chance. I live downtown LA, so I'm just completely out.
In my
Kate,
defense,
where are
some people watching online might also be theorists and might need this also explained to them. That's all I'm saying.
And yes, so the lower the number, the brighter the object is.
Yeah.
As well.
The only way I was able to find is I put the coordinates in my scope, and my scope sort of magically went to it, and I said, "Oh, there it is."
Magically.
Magically.
No science at all.
No.
All magic.
Or engineering.
This comet actually came pretty close to Venus last month. Unfortunately, there was nobody there to see it. It would have looked pretty cool. We were actually talking about maybe trying to observe it from Venus Express, but we didn't. It didn't quite work out.
Well, what are the odds of a comet coming near another planet where we could see it with robotic explorers there?
Right.
Oh, wait.
Yeah.
Oh, wait.
So when is
that was a good segue.
when is that happening?
It's It's when Maven gets to Mars, which is what, this fall, October, and then isn't it like 3 weeks later? This comet comes really close to Mars and will even possibly cause a meteor shower there, which is kind of crazy.
It seems unlikely at this point, but it's comet sighting spring, and it's I don't remember the miss distance now. I'd have to look it up. It's going to miss for sure, and it's probably, they're saying it's Mars. It's going to miss Mars, and there may be some gas from it that'll hit the atmosphere. Probably not meteors, but either way, it's still really cool. I hope we don't lose
like
any.
cyanogen gas? So you have to worry about the Martians getting poisoned by that cyanogen gas from these comets?
Well, after they invaded Earth, I think it's what they deserved.
Yeah.
True. It is true.
Got it coming.
Yeah.
I read that in the book.
Sorry, Martians.
Actually, when they first discovered this comet, which I think was only in like last March or something, it pretty. It wasn't that long ago. It was a long period comet coming in, and the initial calculations had a decent chance of hitting Mars, and it was also. Yeah. It also looked like a much larger object at that point. Like we're thinking it was like a huge comet that was going to hit Mars. So it was briefly really exciting. Now it's like a small comet that's going to come kind of close to Mars. It's still pretty cool.
It's really cool.
Yeah, if you look up Siding Spring on Google, that's just the name of it. Literally, Siding Spring. It was discovered from Australia. The first hit is the NASA Mars site, and it's got a lot of information on it there. October 19th is when it's going to pass.
Hey, Phil, we have a question from the audience. And by audience, I mean
Yes?
to Farley. Are you moving?
Yeah, you look like you're like a transient.
Where are all your books?
I don't know what you're talking about.
No, he's living in the Home Depot right now, as you can see by the boxes behind him.
All right.
Actually, yeah, we're moving to a different house, not too far down the road, and when I was setting the camera up, and I thought that's gonna look really bleak behind me.
It's okay. We moved offices recently, and I had a terrible backdrop for several weeks on our Hangout, so it's all good.
Okay. So what was that on your right wrist I just saw?
Oh, this is a bracelet that was made with a 3D printer.
Oh,
actually, Pamela ordered it. No,
really
Pamela
cool.
ordered it and gave it to me. So yeah.
Okay, I thought it was a tattoo.
No, not a new tattoo.
Okay.
So, are you in charge of the camera over there, Nicole? Can you head over to Gary's image?
I am. I can totally do that.
Fraser, I believe, is on a plane right now. and we
Fraser's
get
on a
to-
plane, so you've
So
got
we
me.
get to
You've got
his
me
favorite.
driving mildly inebriated. So
That's totally fine. This is why you and I work so well together, because we're like, screw it. We're gonna get all Bill O'Reilly and just do it live.
what?
So, this is Fraser's favorite image, and he's not going to be able to see it.
It
but
matches my hair, you guys. My
It
hair
does.
is totally H alpha right now.
It's beautiful.
So, what are we looking at, Gary?
This is the Rosette. I just put it up. This is one that I took some time ago. I am acquiring the first image right now. I'm bringing up the Swan, so I'll have it in about 3 minutes.
Nice. So tell us, PhD astronomers that we have in here, what is the Rosette Nebula besides beautiful?
Yeah, so
Crickets.
nobody's going to jump in unless you poke somebody specifically.
I will totally call out Nicole because she's a radio astronomer, and ha. So what are we looking at, Nicole?
I just put my headphones back on. What's happening?
You have to give us all the answers to everything now. No, what are we looking at? What's going on with the Rosette? What is
The
this?
Rosette, is this a star forming region? I don't actually know off the top of my head.
Is the telescope too small? Do you need something bigger?
I
to
need
know what
longer
it is?
wavelengths.
Yeah,
I
okay.
need longer wavelengths. But when I see a lot of H alpha, I see
Yeah.
hydrogen gases being excited by ultraviolet light from baby stars, and so that's why I'm going to go with star forming region.
And this is shot in H alpha, right, Gary?
This is actually in H alpha, oxygen, sulfur 2, and oxygen 3.
Awesome.
Oh, okay.
So
there's not much
The
else.
red is the hydrogen alpha.
the red's the hydrogen alpha, so that
Yes.
is a particular line. What are oxygen and sulfur? What is oxygen green?
Yeah.
Oxygen is oxygen's blue, and I've
Blue,
mapped
okay.
sulfur
Oh.
as green.
Okay.
Oh, I see. Yeah, usually O3 is green, but you've got sulfur in there, so I guess that makes sense.
Yeah.
Yeah, and you can map them to however you want. There's different
Even
maps.
then,
Yeah.
that's funny. It doesn't look like there's much O3 in there.
Yeah, I just see hydrogen.
Yeah.
There's like a little magenta swath through it.
No, that's amazing. I'm going to head over to one of our other images. This is submitted to us from Chris Kennedy from the UK. And this
Before
is
you
M15.
jump,
Yeah.
Scott,
Go ahead, Gary.
this is the where I mapped the hydrogen as green. Same
Nice.
image.
Oh, wow.
Yeah, I love that.
That's
I just did
bizarre.
hydrogen as green.
That's amazing.
So, go ahead. Sorry to interrupt.
No, you're fine. Someone has to drive it over because I'm not in charge of this. I'm just talking and drinking, so this is great.
At least you're not driving.
Whoever's choosing the image, put it on the screen here. This is from Chris Kennedy from the UK, and we're looking at an M15, which is a globular cluster, or as the rest of the world calls it, a globular cluster. And I will not make my really bad astronomy joke about this, so because they're the old things, and they're sitting there on their rocking chairs going, "Damn you kids and your heavy metals." What are we looking at? Who am I going to pick now? I'm going to pick David. Can you tell me anything about globular clusters?
Well, I can't tell you that much about them. I'm a planetary scientist, damn it, not a astronomer. But I think they're dense, gravitationally bound clusters of stars that sort of are out in like the halo of the galaxy, and they're old, right? But I'm not actually that up on my galactic astronomy, other than I think they're beautiful objects and they're fun to look at. They're one of the kinds of things you can find in telescopes if you're a total amateur
right.
at observing, as I am. I'm more of a theorist and a spacecraft user too than a telescope user. So
theorists represent.
Yeah.
How did we get all these theorists on the VSP? What happened? What happened, guys?
We're taking over.
But what I'm actually wondering about, and which maybe one of you astronomers can comment on, is what are the prospects for planets in globular clusters? I mean, they're old, right? And so what would it be like if you were living in one of these places? Would your sky just be filled with stars from your fellow globular cluster mates? I mean, it would probably be kind of a cool place to live, right?
Yeah, I've actually written about this. A long time ago, I wrote an article about what it would be like to stand on a planet in different places, and one of them was in a globular cluster. And it would be amazing. I mean, these stars, what you've got here, I mean, M15 is a little over 30,000 light years away, so it's decently far, but close enough that even in a small telescope you can see it. I remember looking at this one when I was in high school with my telescope. It's in Pegasus. So it's not that hard to find. It's up pretty high if you're up in the northern hemisphere. Sorry, Katie. And it is old. It's about 12 billion years old. And the stars you're seeing there are so old that all the really high mass stars are gone. They've exploded long ago. And what you've got left are stars that are even lower mass than the sun. Even the sun is going to be gone by the time it's 12 billion years old. So some of those stars, though, are old enough to be red giants, and they're very bright. And so if you were standing on a planet in that cluster and looked up in the sky, if you were sort of in the outskirts of the cluster, up in one part of the sky, I should look at my image so you see. So if you're looking up this way, it's really awkward, you would actually see the cluster itself. You'd see a lot of stars in that direction. There are 100,000 stars in these kind of clusters or more. And so the sky would be filled with stars, and some of them would be extremely bright. You'd probably have a good chance of seeing a dozen or more, or hundreds, if you're in the right cluster, that are brighter than Venus. So it would actually dominate the night, kind of like the way the full moon does here. It'd be gorgeous.
So you can see your star shadows.
I would think so, especially if you're on the outskirts of the cluster, so we're all in one spot in the sky, not spread out. But the problem is the stars are really old, which means they have not had a lot of metals in them. They don't have a lot of heavier elements like carbon and oxygen and that sort of thing, because
hence my really
they come
bad
from the young universe. So they probably don't have planets. I don't think any planets have been found around normal stars in the globular cluster yet.
Okay, so that's what I was wondering. So it's not really the kind of place that, as an astrobiologist, you would necessarily pick to go and, or if you were Kirk and Spock and kind of, surveying for planets with life, it's not necessarily where you would first go in that sector unless you were like really bored and desperate.
Yeah, and it's also
Yeah,
a
do
long
you
way
want to
away.
look for hydrogen and helium? Let's go there.
Hey guys, we have a question from Josh in the audience here at Emory University. How far away is the M15 globular cluster? We lost you guys for a few minutes. If you already talked about that, we're asking how far away it is.
I just looked it up. It's 36,000 light years.
So pretty
So,
close.
so
Right
our
next
Milky
door.
Way is a flat disk about 100,000 light years across, and this is well out of the plane of the galaxy. So it's roughly the radius of the galaxy way, very, very, very roughly.
And what causes these things to form in these dense clusters and be distributed outside the plane of the galaxy? Do we have a good explanation for that?
Not one I've seen, to be honest. That's a good question. They form separately from the galaxy, but at the same time, because 12 billion years, that's about how old the Milky Way is. And some galaxies like M87, which is a nearby massive galaxy, has thousands of globular clusters. We have about 150 that we know of. There's probably a few more we haven't spotted. I don't actually know. We need a theoretical stellar astrophysicist for that.
We
My
need to hear it.
guess-
Hey, Katie, you're
Yeah, go Katie.
It's probably dark.
So I mean, my understanding was that these things are sort of fossils of earlier structures that they're sort of small structures that kind of fall in and circle around, and some of them get kind of torn apart by the Milky Way's gravity, and some of them kind of just get more condensed and stay these really compact objects. I'm doing a lot of hand waving because they kind of, like here's the galaxy disk, and they're kind of doing that, Anyway, so my understanding was that they were kind of they were left over from when the galaxy was first coming together, and you had little clumps of dark matter in different places, and there was little clumps of gas, and some of those formed these stars really early on, and they're kind of circling around. But yeah, I don't know a lot about the specifics of how these things formed. I don't actually know how much dark matter they have compared to other galaxies, or if they're mostly gas dominated. I know they don't have a lot of gas. I know they have a lot of stars.
That's a good question. I wonder if it gets tidally stripped away by the galaxy. I never even thought of that before. That's weird.
Well, would you be able to tell by looking at their sort of orbital dynamics and seeing if it was consistent with the amount of visible matter, or if there was a requirement for some other mass? Or is it not that easy?
You should be able to tell, but you have to have a good sort of survey of the number of stars. I think you should be able to tell, but I don't know. I know that there are dwarf galaxies that have very few stars, that are very dim, that are very dominated by dark matter, but I don't know about globular clusters. The thing is, globular clusters are pretty low mass compared to galaxies, and we don't know a lot about how dark matter is distributed in small mass objects. So we don't know. It's very hard to tell with things that are less massive than a galaxy how much dark matter they have.
Interesting.
That's totally globular, man.
Yeah, totally. It's even kind of globular as well, if you're from Vancouver. And we're joined here, too. I'm going to introduce real quick. We have Peter Lake joining us from Australia as well, but he is controlling a telescope in New Mexico. Is that right? Maybe?
Yeah.
Yes?
Yes,
Correct.
Yeah, okay. So,
Correct, yeah, sorry.
so Peter, you've got a telescope on the IE Telescope Network, and so you told me that you're pulling some images down now,
Yes.
which is awesome, and I'm still screen sharing. So welcome to the show, Peter. We are live online and in Atlanta. So hello, everyone in Atlanta, and welcome, Peter. I'm going to share another image real quick before we make our rounds again, because I think this is beautiful.
While you're doing that, I'm going to do a quick plug for the event that we are doing here at Emory University. This is the Atlanta Star Party. This is a fundraiser we do every year right before Dragon Con in Atlanta. So if you go to the Atlanta Star Party site, you can actually check out what kind of events that we've had here. We've got this lovely virtual event for you guys as well. And this is all done to raise money both for to study Alzheimer's disease and also to do science education through CosmoQuest. So go over to the website, check it out. If you can donate, hit the donate button. We do this in honor of Jeff Medcalf, the blue-collar scientist who died of cancer several years ago, an amazing, amazing astronomer that got a lot of us into this and actually named asteroids after several, at least one person in this hangout. Right, Phil?
Yeah.
So thank you for joining us. Yeah. So thank you for joining us, all you guys who are joining us here, all you guys who are joining us virtually, and go ahead and check out the Atlanta Star Party webpage as well. Just Google Atlanta Star Party. It's atlantastarparty.com, I think. Yeah, so thanks for coming. And let's move on to the next astronomical pretty.
Yes. So the next astronomical pretty is again brought to us by Ahmet Kale. And I love this. I know Katie and I have talked about this a few months ago, actually, when we were talking about supernovae, and this is the Veil Nebula. And, first of all, beautiful. He just blows us away with this detail coming in here. But what exactly is this structure? And I'm going to put this to Katie, because we have had a hangout on what's going on here. So what are we looking at?
So this looks to me like a supernova remnant.
Yeah.
So when you have when a star explodes, it blows out all its gas and all its sort of atmospheric layers, and you get these kind of tendrils of gas that are sort of glowing from being hot or from reflecting light from the star. And those can persist for a really long time after the star explodes, and so you can get these really beautiful structures. And over time, if it's a very old supernova, they get really diffuse, and so you get these sort of very wispy structures that are the sort of leftover debris from the star that exploded. Very neat stuff.
Very neat stuff. And again, the processing he did on these images are fantastic. I can actually, if I can pull up the email he sent me about all the details he put into it, it's nuts about how much or how many minutes of exposure he put into each single one of these. But I know Gary has some images too, so maybe I'll have you, if you have those on hand at all, Gary, you can pull up your versions of these as well later on. But
okay.
They're just, I love being able to see, just the geometry of this going on in space. And this happened, I believe, I want to say 3,000 years ago, I think, if this is the correct one that I'm thinking of. But you're seeing the slow disbursement of the matter after the death, like a cataclysmic death of a star. And we're seeing it slowly, quasi-slowly to us, going over large distances and dispersing out into space, and watching how that diffuses out. And I think it's absolutely beautiful. And do you have anything to add here, Phil, as well, to anything with the Veil or supernova remnants?
I heard my name, but everything you've said in the past couple of minutes has been really garbled. Is anybody else getting that?
Sounds okay to us.
No, I hear fine. I think it must be on your end.
It must be the Home Depot you're in, your Wi-Fi signal.
Yeah, all I'm hearing is so I have no idea what you just said.
He said,
I was professing my undying love and affection for you, and you just rejected it, so I'm sad.
I have no idea what's going on.
That makes it even funnier.
Now I hear mechanical Cylon laughter.
I am a Cylon. That is true, actually. So these are, what he took to take this image here are 45 second images. So he's actually, and he's gone and composed these all of 40 separate images and stacked them to be able to get The
45-second images?
Yes.
Like seconds?
Yes.
That doesn't sound right.
45 seconds.
That doesn't sound right. But
Or maybe-
Gary and I are shaking our heads. They said there's no way.
That looks like hours.
Yeah.
So maybe it's 45 minutes, and he sent me the wrong information. But he gave me 40 by 45 on these, so they might be 45 minutes each.
45-minute subs also doesn't. Well, whatever. Yeah.
That sounds about right.
Yeah, but 45-minute subs?
Based on the email. So
All right.
could be something else.
I love watching you guys dork out.
Come on, all right, astro nerds. The other type of astro nerds here. So, Peter, I see that you're pulling up something here. If someone can switch over to Peter. You're
that's a
setting up your
screenshot.
iTelescope network?
Yeah, this is a screenshot of my iPhone, which I'm driving the telescope with at the moment. So
Nice.
not,
The
not
future
to
is here.
show off, but anyway, I will share the last image that came down, and that was that's my telescope. The last image that came down was of M10, and maybe Katie, you can take us through M10. It's a beautiful shot of it there for you all.
That's great.
I don't know anything about it other than it looks like a globular cluster and it
Yeah.
looks very nice.
So this is a Northern Hemisphere object, and yeah, it's quite stunning. We've got a couple of good ones down south here, the Omega Centauri and Tuck 47, which are very nice. This is one of the best in the Northern Hemisphere, certainly.
So this is up in
How many-
Ophiuchus.
How many stars does that one have?
More than one and less than infinity. So I've narrowed your range down.
What's the square root of -12, isn't it?
Right.
You seen that mad video?
And actually, I might be able to find that up here for you're looking at M10 here, and this is around 33,000 light years away from us, and it was discovered in 1774 by Messier. It's the 10th in his catalog, and I'm trying to find an estimation of how many stars in there. Besides a lot, because I've got some other images here, and they're just fantastic. But not an estimation of stars. But it is here. It's around 2.25 times 10 to the 5th solar masses. So we can look at it in that way as far as the masses of stars. So
Alright,
quite a lot.
So around 10 to the 5
Yeah.
stars. Yeah, so I guess globular clusters usually have between 10 to the 4 and 10 to the 5 stars, something like that. So quite a lot. But yeah, it's gorgeous.
And just to give you a prior warning, M27 is going to be next.
Okay. Very good.
So we're going to interrupt with a quick question.
Yeah.
Take it away.
Hi, my name is Ross. We're over here at the Atlanta Star Party, and I was curious, are there standard ways of coloring some of these images? Because I was curious about that.
There are. So with us, so I also work with Hubble, and so we have a Hubble palette that goes through whenever you're getting your images in based off of which wavelengths you're detecting in, and you attribute certain what you're detecting into certain colors, and you're able to play with that. We actually just did a live show last week on calibration and how you actually are able to pull out these images. So if you go to the Hubble Space Telescope YouTube channel, you can check that out there. But there are specific colors attributed to these specific wavelengths that are being detected to be able to pull out these beautiful images that you are able to see that are widely produced, that you see out there that are released by the Hubble Space Telescope. But I also know that other astronomers as well use their own palettes that they like as well. I know that Gary was talking about how he puts specific colors to specific filters. What do you do, Gary?
Normally, I'll use hydrogen alpha as red, sulfur 2 as green, and oxygen as blue. But as you showed you earlier, when I make the hydrogen green, it's a very dramatic picture.
Yeah.
But it's not anywhere near its true color.
And I do red is red, blue is blue, and green is green. I just have just standard filters and then a clear filter for detail. So you can do narrowband, which is what Gary's doing, or just do LRGB and then just stretch the colors out. And it's basically true color, just saturated and brought out.
Right. What I'm doing is very, very narrow band filters. I live in a light polluted area in the Los Angeles basin, and I'm taking very, very narrow hydrogen alpha, which is a red, and I'll let you see me here for the heck of it.
There you are. There's your pretty face.
Yeah, a very narrow hydrogen alpha, very narrow sulfur 2, and oxygen 3. And these are the lights, these are the wavelengths that are given off when these elements are excited.
Woohoo!
So
I'm
I lock out.
And yeah,
everything else. So what I have is 3 pictures that I can combine in any way I want. So quick explanation.
Does that sound good? Does that make sense?
Yeah, thank you very much. Thanks.
Yeah, no problem. So I've got some more images to pull up here. Let's see. I have some from John Kramer, which are not labeled. Actually, I do have some that are labeled. So let me pull up the ones that are labeled. That will make things a lot easier on me, so I don't have to guess too much. This one here is the Ring Nebula. And you can guess why it's called the Ring Nebula. Because it looks like a ring. Scott? Because it's from Mordor, and we're all going to die. So this is a planetary nebula, and I will let our astronomers take facepalm, Nicole. So you are now in charge of explaining what goes on with planetary nebulae.
I win. All right. So this is really weird because I'm echoing by like a second here in the planetarium.
This is amazing.
It's really distracting. So the Ring Nebula is a planetary nebula. It's what's left after a star like our sun dies. So it doesn't explode the way a massive star would, but it slowly sloughs off its outer layers. And those outer layers, the gas is actually being excited by what's left from the star, the core of the star, which is a white dwarf, a very small but a very hot remnant of a star. And so the ultraviolet light from that is exciting the atoms in that gas from the dead star's envelope or outer layers. It's a fairly short-lived process. I think it's only tens of thousands of years that a planetary nebula phase is actually visible. So a star like our sun won't go out in a bang, but in a whimpering but very beautiful planetary nebula. We hope.
In a puff? In a
paw.
Why is it called a planetary nebula?
That I don't know.
I believe it was Herschel, but go ahead, Phil. You seem like you want to answer this question. Phil, take it.
Go ahead. Get started. Go ahead.
Go, Phil, go.
A lot of them, like the Ring, are small, compact, and they are dominated by the light from oxygen, which is green. And so a lot of them look like Uranus through the telescope, little green discs. So they were called planetary, like meaning planet-like. And then for a long time we said, well, they have nothing to do with planets. They're just when stars die. Then in the 80s, late 80s and early 90s, I want to be accurate here. It was in the 90s. The idea that a lot of these things, if you just have a star blowing off its outer layers, they should all be spherical. Very few of them are. Actually, there are only a handful that are spherical. Most of them are weirdly shaped. The Ring Nebula, in fact, isn't round. It's barrel-shaped, and we're looking straight down the barrel. So it happens to look round, but in fact it's elongated. And we think now that as the stars die and swell up, they're engulfing their planets. We're seeing a lot of planets around other stars that are as massive as Jupiter, but very close in. So when the star puffs up, that planet is actually swirling around inside the star, spins the star up faster, that blows the wind off in these weird shapes, and it's what's sculpting a lot of these nebulae being very weird. So in fact, they are sort of, sculpted by planets, but it's after the fact.
So fortuitously, it was actually a better name than it should have been. That's kind of cool.
Yeah,
Here's
I've
another
always
example
got
of one here. This is
here's one.
M27.
There's the dumbbell.
Yeah. So this
Yeah,
one we're able to see in color, and this is
there's-
another type of that planetary nebula.
That's a great shot.
Yeah. And this is from Ahmet in Turkey, who just blows me away with all of his astrophotography. It's just phenomenal. But this is another way, as you can see here, the greens coming out from that, and in the early observations, you're just seeing this palish greenish blue light, which looked a lot like, planet Neptune out there. And we're seeing that, which it looks planet-like. But now we're seeing that there's much more going on there from the depth of these sun-ish like stars, and our sun could happen like this or might not, but they're beautiful. They're actually one of my favorite objects to observe because they are just so gorgeous.
There's a ton of fun stuff going on here. The green is from oxygen, and there's not that much oxygen. Hydrogen dominates hugely, but oxygen has, in the way its electrons are configured, when you blast it with the ultraviolet light from the star, it gives off light very, very strongly. So even though there's a lot more hydrogen, per atom you're just not seeing as much light coming from each one. So the green dominates even though it's not the most dominant element, the oxygen isn't. Plus we're also much more sensitive to green light than red. So by eye, these things look really green through a big telescope. Through a little one, they just look gray. But I've seen a couple of these through a bigger telescope by eye. And yeah, you can spot the green color in them. It's creepy.
Creepy planetary nebulae. Yes, absolutely.
Green is a creepy color.
Hey, don't hate on my eyes. I can't help it. So let's hop on over to Gary's image, whoever's driving the internet on that end in Atlanta. And what do you have for us, Gary?
This is the Eagle Nebula, M16. It is 10 seconds with each filter. I tried to do a 1 minute, and it wasn't dark enough yet. It blew it out. So this is 10 seconds, red, green, and blue, combined, just stretch, no processing at all. So normally you can see the gradient in the background. I've got green over here and blue over here. And the processing, I would filter that out, bring it out, but it's just like chembothoscope. This is as close to live as you can get.
And this is in the LA basin, by the way. So this is where we have terrible light pollution.
Yeah.
Yet when you're able to filter out all the junk light that's being bombarded around us, you're able to actually pull out some really beautiful images.
So I've got some 1 minute exposures coming up here that it got dark enough I could do it now.
Awesome.
So that's the Eagle. Right here in the center is the famous Pillars of Creation.
And just so you know, your image is blinking on my end too.
I know.
Okay.
I've got something wrong with my display program, and I don't know what it is. Is it
Yeah,
really annoying?
You should talk to the software developer there, Gary.
Yeah,
I know. I
heard he's a jerk, though.
Is it enough that it's up? You can see it, Scott?
Yeah, I
it's
can
fine.
see it. If I blink at the right times, it's perfect. So.
Okay. Oh yeah, it's staying there.
Yeah, you're good. No.
Okay. That is the Eagle Nebula.
Beautiful. And it looks like Peter has a planetary nebula as well. What are we looking at over there, Peter?
Yeah, that's my image of M27, just come off the scope now. And yeah, it's lovely. So that's just one color channel. It's a luminance filter there. So what you saw just previously was after many, many hours of processing. This is one single image straight off the scope where you would then combine that, stack it in the various color channels, and then combine it. So.
Oh, that's nice.
Yeah, it's very nice.
And not, I'm going to just toot your horn for a bit because I know the telescope you're using, and you don't have a little, like I set it up in my backyard telescope. What telescope are you using, Peter?
I'm using. I'll just show you. Where's my screen share going here? I'm actually driving the Planewave, half-meter Planewave in New Mexico from my iPhone here, and I'll just prove it to you by doing a flip of the iPhone screen. so yeah, I'm using trying something a little different today. I'm using reflection here on the iPhone to capture the screen, and you can see the output script of the telescope running here, and
Yeah.
it's just finished photographing the M27. So we can go here and we'll do a one-click image from a list of known objects that are in the sky at the moment. Most of them are clusters. You can see that was the one there. I just went and grabbed that off the telescope, but usually I think would M17 should be up now, shouldn't it? Yeah, I think you just did that, Gary, didn't you? Is that right?
I don't believe
So-
Gary did, but if you want, but
No, no.
I know you have an image of your telescope, and
Yeah.
it's enormous.
Yeah. So I'll
Can,
just.
can you show that with us? Because it will give many people aperture envy.
So you can see it over in the corner here in the. Let me just see if I can find an image of it to share with you.
So you know,
I'll-
his primary mirror is a 1/2 meter, where Gary's using a 14-inch, I believe. Is that right, Gary?
14, correct.
And these are reflectors, and then Stuart is using a refracting telescope.
Yeah, it's
Yours,
about-
130,
140 millimeter.
140
Just
millimeter,
like 5.5 inches.
right? But it's a refracting telescope,
For refractor, exactly.
right?
And now we're discussing size.
Yes,
Uh,
because that never happened to astronomers ever,
we wouldn't go there. No.
never. So while you're doing that, I'm going to go ahead and share another one here. Again from Ahmed, because he just blows me away. This is M101, and holy wow, this is just
Wow.
beautiful,
Man, that's striking.
right? I mean, the beautiful colors that are coming out here. Tell me, deep sky astronomers, what are we looking at, and what's going on here? Like, is that a typical type of galaxy? Is it? It seems a little, the arms seem a little on one side. Is there some interaction going on there, or what's happening?
Well, Katie, you do galaxy formation, don't you?
A little bit, yeah. So, I mean, so I can't see if there's something that is currently interacting with the galaxy, but these kind of spiral arms tend to come about when something disturbs a galaxy and causes what's called a spiral instability. So it's like a sort of like a density wave that goes through and disturbs the disk of the galaxy and makes these spiral arms. So this looks like something that has had an interaction that's sort of stretched out that spiral a little bit. But yeah, I don't. There's some cases where you can actually see a companion galaxy, and you can see how it's sort of pulling the spiral arms away. And you can't see that in this one, but I would guess that something like that happened to it at some point to make it sort of stretch out a little bit like that. It's really beautiful.
It does look like it's coming apart.
Yeah.
And so, Miss Dark Matter as well. What do we, so
Dr.
we're looking.
Dr. Dark Matter.
Excuse me. Pardon me. Yes, Dr. Dark Matter. And speaking of which, shameless plug, tomorrow night at 3 a.m. Eastern, midnight Pacific, we will be having our 3rd episode on Dark Matter with Katie Mack on Space Fan News. Shameless plug. And those that are at Dragon Con will most likely still be awake at 3 a.m., so please tune in for that. Dr. Dark Matter, when we're looking at galaxies like this, how do we know that dark matter exists when we're looking at galaxies, especially face-on in this way?
Yeah. So basically, whenever you look at a galaxy like this, you have to take into account that the vast majority of the matter in that galaxy, the vast majority of the stuff that's holding the galaxy together, is actually invisible. It's this dark matter. And what you can sometimes do with spiral galaxies is you can see, you can measure how fast bits of the galaxy are rotating around. So they're sort of going around. The stars and the gas are all rotating around the center of the galaxy, and you can tell when you look at those speeds that the parts on the outside are going far too fast to be held in by the galaxy unless there's some extra gravity holding it all together. And we think that extra gravity comes from a sort of halo. It's a sort of a spherical-ish distribution of dark matter enveloping the galaxy and holding it all together. So so that whole thing is kind of rotating in the sort of plane that you can see there, and the parts on the outside are going a lot faster than they could if there wasn't any extra matter holding them in. If dark matter wasn't there, that whole galaxy would just completely fly apart, and all of the stars and dust and everything on the outside would just fly off into space. So the only reason it's able to stay together like that is because it has this massive dark matter halo holding it all in, and that's about, like, usually about 85% of the matter in the galaxy is right. Dark.
And it does not interact with EM at all. So it does not interact with that force at all, so we can't see it, but we can see the effects it has on space-time.
Yeah, the only thing that we observe it doing is messing with gravity. It has mass, so it holds things together. It changes the gravitational field. It has its own gravitational field, so it's sort of messing with space-time in the sense that anything that has mass is sort of contracting space-time around it, but it doesn't seem to interact with light at all.
Which is awesome. And it's 85% of the matter, which, you're like, oh, there's so many things out there. Yeah, and that's nothing from what there actually is that has mass. So
yeah.
I know, Stu, you have more images that you sent me, and you've been quietly drinking there in a corner. Do you want to share with us some more of your images?
Sure. Do you want to do it, or?
No, you can do it. Go ahead and you can do it.
All right. Well, then let me pull them up and go into some. Go to Gary, and then I'll get one.
All right. Go ahead to Gary. What are we looking at?
You know what?
We're looking at your
I'm
face.
this opportunity to sign off.
Let me bring it up.
Yeah, Phil.
My feed is coming and going, and it's a mess, and I have to run anyway. So
okay.
I have to go. I'm going to say goodbye.
Thank you for showing up there.
I wish I were there. First Dragon Con I've missed in many years.
Phil, it's not the same without you. What can I
It's the first VSP you've been in a few years, so you kind of balanced it out. So
that's true. I've just got too many other things going on right now.
Well, again, thank you, and I'm sure we will see you again soon.
Tim says
all right,
hi.
thanks everybody. See ya.
See you, Phil.
Bye. All right, so Gary, what do you have here? Is this the monkey head by any chance?
Nope, not the monkey head.
No.
This is M8, the Lagoon Nebula.
This is the Homer?
This is the Borg Homer.
Borg Homer.
The Borg eye here, the nose and mouth, and the wispy hair. So this is the Borg Homer, and again, I apologize for the blinking. It's something in my video driver.
Oh, I see it.
I gotta see this. It's a classic now. Oh, I see it.
Yeah.
Inside jokes. So, where is this exactly?
In the sky.
Yeah. Good.
This is.
I'm glad that you're not projecting into my brain right now, because that would say all sorts of things about my reality.
Tell you what I did. This is 1 minute with each filter. Again, no processing, just slammed together as 3 colors. What constellation it's in is it's got Sagittarius.
Sagittarius, okay.
Yeah, I think it's Sagittarius. I don't have it up showing the outlines right now.
Okay. But this is Homer if he became part of the Borg.
Yep.
Which is terrifying. I mean, not really terrifying, because really what's he going to do besides just consume all the resources and get kicked out eventually?
I want the fan fiction now.
All right.
Needs to happen.
All right, you know what? We've been threatening to do a podcast for so long. Let's totally do a fan fiction of Borg Homer.
Dear God.
Yep, and we'll get Sigler on it too. So I'm going to hop over to Stu now that he's got something up here, and this is your color image of the comet we were looking at earlier.
Right. So this is the same. This is the same comet we were looking at from the same imaging run, and it's obviously not animated. But it's what I was kind of surprised was how green it is, and it turns out that this is the color that it really is. And I was hoping that one of the astronomers that are here could tell me why it's so green, because what element in it makes it greenish. Anybody know? But
boogers.
we've got 2 theorists and a radio astronomer, so
So we're screwed.
Cyanogen and junk like that, but I don't know exactly if that's what's causing the green.
Yeah,
But,
it's something to do with what it's made of, but I don't remember
what
I
it
don't
is.
remember which chemical it is.
Yeah, technically this was a difficult process because you have to align on the comet, create the color on the comet, and then superimpose the comet on the background stars. So it takes multiple steps to try to get it to look like this. So it was a nice challenge for me.
Yeah, it came out great. I was really glad when you sent the color image to me earlier, because this is beautiful, and you should share that with the world because it's beautiful.
Thank you. Yeah.
Yeah. So I'm going to hop over to Peter because I have no idea how much time we have, so I'm just going to go until Tim tells us to stop. But I'm going to hop over to Peter's image here of the swan, I believe.
Yeah, so this is M17, the Swan Nebula. It's kind of my signature. Astro Swanee is my Twitter handle. So
Hey, we're gonna wrap up in a few minutes, so maybe a couple more images.
Cool.
Awesome.
That sounds great.
So
And then say hi to all my friends in Atlanta that I don't get to see. I love you all.
Mwah.
hi.
Look!
Oh.
We put up the website now. So AtlantaStarParty.com. Come check it
Oh.
out. Okay,
Check
back to
it
the
out.
images.
Back to Peter.
So this is M17, which is the Swan Nebula. It's also known as the Omega Nebula, which Gary had up before, as you saw. This is a processed image of mine that was taken a few years back, and I just love this shot. It's just captures the whole. Now, if you kind of look at it, you can almost see an Omega sign there as well. Or if you turn your head to the right, you'll see the Omega sign. If you turn your head to the left, you'll see a white swan gliding on a lake. So those of you who know me and know my musical bent is where the Astro Swanee handle comes from. So
Nice.
So lovely image, and I've got M16 just coming down now, and that should be ready in a few minutes. So back to you,
Beautiful.
Scott.
That's beautiful, Peter.
Yeah, it's really nice.
So
we
I'm
have a question from a little while back from
Yeah.
JD Mack, friend of ours in the DC area. Does a globular cluster have a black hole in the center? So this is similar to how many galaxies have black holes in the center. Does anyone want to take that about whether globular clusters have a black hole in the center?
So this is actually a little bit this is sort of controversial in the sense that we're not really sure. So there's been a lot of effort to try to figure out in general if globular clusters have black holes, and there's been some evidence for, some evidence against. So it's not at all clear. They might not. At last I checked, it was still sort of, there's something they're trying to figure out.
We also have a question from Michael Jobin, who is a regular of a lot of our hangouts.
Yeah.
Is the apparent size of the Dumbbell Nebula, the apparent size in the sky, similar to that of a planet such as Jupiter, or is it bigger, smaller?
I believe it's tiny. I think it's really, really small.
Yeah, I don't know about the Dumbbell. I know the Ring Nebula you can resolve just barely with the 8-inch telescope I use for public outreach. So I would say it would be bigger than Jupiter. Anybody else have a?
I can look it up.
Okay.
Okay.
I think it's a bit bigger angular size-wise, or apparent angular size-wise.
And speaking of planets, I'm going to hop over here too. These are from Malaysia. This is from Shaw. And this is both Mars and Saturn showing up in the same image. And guess which one's Mars, everybody? Guess
The
which
white one.
one's Mars?
I'm going to go with the red one.
Yeah. So we have over here Mars, and we have Saturn over here. Now, Mr. Astrobiologist, tell us about the exciting things going on around Saturn. Not necessarily Saturn itself, but its natural satellites.
Yeah,
Are there
it's
things
just-
that could be going on there?
The Saturn system has just become more and more interesting as we've explored it with the Cassini spacecraft. We knew that Titan could be potentially of interest for astrobiology, and when we got there with Cassini, we had some speculation there might be liquid on the surface because it was about the right temperature for liquid methane, and we knew there was methane in the atmosphere. But we really hadn't seen the surface at all, and now, of course, with Cassini and its infrared and radar instruments, we've been mapping and observing the surface, and we see, and with the Huygens probe, which went right down to the surface, we see that there are rivers and lakes and a whole sort of hydrological cycle of methane and all kinds of juicy chemistry going on, and it's pretty enticing, the possibility that there could be some sort of exotic, even possible biological activity there on the surface in the liquid methane. Is there's energy for metabolism, there's organic matter, there's not liquid water, so it depends on what you think you need for life, and we just don't know. But it's certainly a place where there's prebiotic chemistry going on, the kind of chemistry that was going on the early Earth that led to life. So, so Titan's really exciting, and then in the Saturn system, yeah, we also have Enceladus, which apparently does have liquid water, where we see this.
It's shooting out into space.
Plumes shooting off the southern pole from these tiger stripe areas, shooting off into space, and it's thermally weird. There's this hot area around the South Pole, and there's probably stuff on the surface of Enceladus. It's snowing down the stuff that's coming out of these vents, and so if you went to Enceladus with a snow shovel, you could go and sample the interior of what's going on that planet and look for organisms.
That's so awesome.
So there's a lot of going on in that Saturn system that's really much more interesting to astrobiologists than we would have suspected before the Cassini mission.
Right.
Isn't there some kind of a vague plan to send a spacecraft to sort of fly by and pick up some of the stuff that's shooting out of the planet or the moon?
Well, yeah, there's a proposal. There's several proposals. There's not a funded mission to do that, but there are a lot of us that think that would be a really great thing to do, because now that we know that there's stuff coming out where you could essentially sample the interior of Enceladus by flying through that plume or by scraping up some of the stuff that's falling onto the surface from that plume, that it seems like is something that's too good to, how could we not try to do that? But, it's expensive and takes a lot of time to get out to the outer solar system, and there are other missions, we want to fly a Europa mission, and so it's not necessarily the next thing we're going to do, but it's something we have to do.
I know that we're doing things with, we have a Clipper thing in the process for going to Europa, that they're working on at JPL, so there's lots of really awesome things. I'm really sad that we're going to be ditching Cassini here soon. Like literally ditching it, but for a good reason to be ditching it. We're
being responsible citizens of the solar system. We are going to crash Cassini into Saturn on purpose while we still have control of it, to avoid the possibility that in the future we would splatter it onto one of these potentially habitable planets. It's planetary protection, and it may seem unlikely that we would accidentally contaminate one of these other worlds, but
it's us, it's humans, and we send spacecraft with both metric and imperial units at the same time. Because,
I actually think it's a nice hallmark of humans that we have this planetary protection policy, and that we do think about how to sort of responsibly deal with our junk up there, to the extent that we can, and that's the reason we're crashing it is because there's this policy that we don't accidentally contaminate other worlds that could be habitable, and I think that's actually sort of one of our better attributes, that we worry about stuff like that.
And I love that there's actually a person employed at NASA, I think, whose title is Planetary Protection Officer.
I want that title.
Cassie,
I have to look at a badge and everything.
I had dinner with her the other night, and she has a badge.
Yes.
She has dark glasses, and she could do like the whole Men in Black thing. Yeah, it's pretty cool.
That is fantastic.
I am also immensely jealous of this.
She is the Planetary Protection Officer.
That's I can only imagine what type of gun she'd be trained to use. Like, is it a noisy cricket? Tell me it's a noisy cricket.
It's a flashy thingy.
Okay. Gotcha.
All right, guys, we've got to wrap up here at Emory so we don't overstay our welcome in the planetarium here.
Yes. Well, thank you everyone.
Yes.
Thank you everyone in Atlanta for joining us, and hello everybody. Hello to all my friends that I don't see out there. I miss you all.
You got to come to a Dragon Con, Scott.
You know, once I get paid more, then I will do it.
I hear you. I save all year. I used to save all year for this when I was in grad school. So, it's worth it.
I want to go through and thank everybody that joined us. David, Dr. Funky Spoon.
Hey, thanks a lot, Scott. This has been really fun, and thank you all. Really great to see you all and meet the rest of you and hang out with you, Scott. It's been a pleasure. Thanks.
Absolutely, Gary. As always, thank you for bringing your amazing images. I love it.
Well, it's been a pleasure. Been a lot of fun.
Fantastic. Katie, I'll see you tomorrow in like a little over 24 hours. And again, shameless plug, at 3 a.m. Eastern, midnight Pacific, we will be doing our third installment of probably 4 on Dark Matter. So stay tuned for that. We'll be tweeting all about it. But thank you again for joining us. It was kind of last minute, and I really appreciate you hopping in from Australia, from the future.
Thanks, Katie.
And another future member, Peter. Thank you again for joining us from Australia.
Taking you out with the M16 image here and staggering beautiful. So I love that.
Yeah.
So thanks everyone for having us on the show. I'll catch up with Katie, I think, in a couple of weeks when Pamela gets out here. So looking forward to that as well. So catch you all soon.
Very good. Stu?
And I'll take you out with the Crescent Nebula and Hydrogen Alpha that I took a few nights ago.
So nice. So pretty. Thank you for joining and being patient with us while we get our act together over here. Nicole?
What's up, Scott?
I've missed you.
Mwah.
Mwah.
Thanks for joining us here at the Atlanta Star Party. This happens every year the night before Dragon Con starts. So if you come to Dragon Con or if you think you might want to come to Dragon Con, this is something you want to put on your calendar.
Yes. So, again, tell people where to go to support science education before we sign off.
AtlantaStarParty.com is the website for this event. There will be a donate button there. You can donate. It'll go to Alzheimer's research as well as science education through CosmoQuest.
Fantastic.
So check that out.
Again, I am Scott Lewis, your normal host for the Virtual Star Party and also co-host for the Hubble Hangouts. We're on hiatus right now for a week and a half for Hubble, so I get to have fun adventures. So,
Scott, when does the Virtual Star Party happen?
The Virtual Star Party, I believe I have planned for the 7th of September is when our next Virtual Star Party will happen. So 7th of September at 7 p.m. Pacific, 10 p.m. Eastern is when our next Virtual Star Party will happen. And all of you here are more than welcome to join and have fun and be nerdy with us because we appreciate it. And we are now, I think, officially the longest running show on Google+. Because other show one show that was before us actually just kind of went on hiatus for whatever. So we're now the longest running show.
For coming up with these idea to hook up telescopes through Google Hangouts.
Yeah.
All you guys bringing us the night sky. We are entirely spoiled by you guys and your work, so thank you.
Yes. Well, thank you, everybody. We're going to sign off now. Have a wonderful night. Have a safe rest of your week.
Thank you, Tim Farley, for doing all the tech on the Atlanta end.
Yes,
Tim. Say hello. Come say hello.
Yes, Tim.
Tim Farley.
As I bombarded you with emails what's going on?
Tim Farley. Tim Farley. Awesome. What's the harm?
What's the harm? Awesome. Well, thank you again, everyone. Have a great rest of your week, and we will see y'all later.
Bye. Good night, everybody.
Good night.